Hi, I'm Mark Wielaert, and this isn't Frank Eichler. Sorry, uh, he couldn't be there. Um, but well, I will try. It's a bit of a pity because Frank actually did all the work. So that's not completely true. Frank did most of the server work, and the client work was done by Aaron Mary, who is also not here. But well, so if the presentation is lame, that's on me. The code is actually pretty good. Okay, we all three work for Red Hat. But the goal was very explicitly not to make something just for RHEL or Fedora. So, okay. So the summary is we have a debuginfod daemon. We realized too late it should have been dwarf daemon, of course, but well, now we're stuck with the name. And it's essentially just a file server for debugging artifacts. Why would you need debugging artifacts? Because maybe you have bugs in your code. Some people do create lots of bugs in their code. So that's not a problem. You debug your program. You install all your debugging stuff. You use a debugger. Not going to talk about that. A debugger. Yes, what is a debugger? A debugger is anything to introspect your program, basically. Anything that uses this kind of debug info that we serve. Right. It is about native code. If you write in some scripting language, you're already happy because you always have your source code with you. Yay. It is relevant for Go or Rust. There are some improvements that could be made there, but they're not really relevant. It should kind of work out of the box for Go or Rust too. Well, I will show a demo of some of the things that work with it. So for the debugging info, basically compilers these days are pretty good. Always use -G, and you do use GC, which has for tracking assignments, which makes things really, really nice. And don't disable them. The kernel disables for tracking assignments, which makes debugging kernel codes really annoying. Apparently, kernel hackers don't debug. There was once a bug in GC that generated something bad, and since then, the kernel has disabled this. Don't do that. Just use a fixed compiler. Sorry. There are various tools that can compress your debug info, which is kind of useful because it's really big. Show some examples of that. There are some subsets that you could use, which are already useful, well, like Conrad showed, but we want more. That's basically it. And there's the source code, which is also pretty big and which is kind of interesting because you don't want the source code the pristine source code, but the source code that was actually used to build your program, which is sometimes different because your build might pre-process your sources or generate them on the fly. In general, you use -G and you're happy, except if you don't, or if make strips it, well, then we really can't help you. But you might be using someone else their builds, or well, distro packages, or you might be debugging remotely or in a container or from outside a container, and where are your where's your debug info? So the idea is in all those depends, we want to provide you with one way of getting at your debug info. Right. So why doesn't everybody ship all their debug stuff? Because basically the debug info is your reverse compiler that goes from binary to source, and describing that is, oh, big. It's 15 times the size of the script executable. So yeah, especially if you would like to have it for a complete distro, it's really big. So no wonder that people try to move it away, and it might be hard to get at. Most distributions at least provide you with some way to find it. So Fedora does it pretty nicely, I think, but I work on Fedora, so that's as you can see, GDB just says, well, just DNF debug info install that package, and it even gets all the dependencies, and so Vim might rely on glibc, so it also pulls in the glibc debug info. So that's it just works, except you have to be root for it to install it, and it's pretty big, so you have to have the disk space, and well, for Ubuntu, I'm not that familiar with it, but that also makes it immediately harder for myself. There is a difference between debug sims and debug DDEPs. It seems both Debian and Ubuntu now produce debug packages for everything, but basically you have the same limitations. And then you have other distributions which don't create any debug information. So what do? Well, you rebuild your program with debug, and you hope it's the same program that you debug then. So the NixOS kind of always has an interesting approach, which is a dwarf file system fuse thing, which is actually pretty nice. this is kind of what we want, although we wanted something slightly simpler and something that that is easy to set up for both distributions and your local builds. Right. So it's pretty useless that you have to have privileges to install debuginfo. It would be nice if there was a mechanism that combines the packages with your local builds, and maybe you have a team that that publishes some of the code. And we always want access to the actual source code used. So the debuginfod is a simple HTTP web server. It has three. It has two. It has three. I missed one. It has three GET requests, one for the executable. That seems weird that you might want the executable, but you might have gotten a core file from somebody, and you want to debug that. So you want to get the executable, you want to get a debug info, and you want source code. And basically, that's the whole HTTP server. They're all indexed by build ID. You can run it on any port, and the servers can federate to each other. So the build ID is kind of the thing that ties it all together. A build ID, well, hex string, basically a hash over your whole executable. It's unique in the way that if you have a reproducible build, it generates the same. It should generate the same build ID, and you use it to uniquely identify a build, but you cannot use it for verification. It's not a security thing. And it's also, if you a build ID is generated by the linker for every loadable module, program, library, kernel module, kernel. And what did I want to say? Oh, yes. When you then split that loadable module, like in the main executable and debug info, you copy over the build ID. That also makes it harder to verify because the build ID is calculated over the whole, so you would have to merge them. The debuginfod is fairly simple. The version that was released, you can point it at your build directory or at a collection of RPMs. In current Git, you can also point it at a collection of deb files. And it uses libarchive, so it can basically use any archiving format that you use. It creates a database, and from that, it serves the files you want. the client is even simpler. If you have support, like in GDB, well, it's not integrated yet, but I will demo it anyway. You just set an environment variable. I have all my debug stuff, my sources there, fetch them, and we have a little example program, debuginfo defined, give me the source, or debuginfo, or executable for this hex code, and with the source byte. That's it. Oh, right. Let me just show it. Oh, right. I can't see anything on this screen. Sorry. So go away. So yeah. Oh, yeah. I said unprivileged, but I'm using Docker files and no. How? Oh, really? It's me. Okay. You script your whole demo and then you can't run the demo because you lost your password. Yeah, let's first show so we don't have any debuginfo installed. We do have elfutils debuginfod installed. Well, just to show that I'm not lying. Yeah. So we start a server with yeah. We start a server with lots of verbosity. Come on. Yeah. So lots of verbosity. Look in create a database here. Scan it every couple of seconds, index all the RPMs and the files that you can find in this directory. And basically, it indexes them, and you're done. Well, we don't really need that window anymore, except to see that it actually gets the files there. Because this is all running locally, the demo is actually too smooth. It just works, and you should see it downloading, but it's immediately there. Oh, I should have shown you. Okay, so in the demo directory, I put the. I happened to put the debuginfo RPMs for BAS and glibc and well everything I need for the demo. This window is too small. Support is built in the elfutils tools, so even though we don't have any debuginfo installed, it gets them from the client, and we have a backtrace with source files and symbols. Nope. So this was for an RPM-based thing. Maybe we want to build something locally. We make a binary, and we strip the thing that we are going to install. So in this scenario, you have your build directory. You give your binaries stripped to your coworkers to run on a different machine, which we now create. Yes. So we use Podman and it. Right. So on this machine which we just created, there is the stripped binary. So we run GDB on it, and there's nothing. This is frustrating. Yeah. So yeah. So now we do it again, but we give it access to the debuginfod server that we are running, and so it uses. Okay, it's cheating. It actually uses the host network, but well, it's as if it is on a different machine. And it actually finds the symbols. You should have seen it download, but it was so fast that it immediately gets them from the cache. And if I do start, yay! I can debug my program. And this would be the scenario where you have a team which presents their own built environment to the server. It also works for system tab. For example, give me all the, you can't see what it's, right. Give me all the functions in glibc that started via printf, and it was too fast again. Actually it got the glibc debug files from the previous run because now they're in its cache. Okay, the demo actually worked. Was it too smooth? Probably it was. Yeah, it should have crashed. I should have made the network slower. But what you can see, actually, do I have it here? No, I don't have it. Oh, right. Oh, I could do this. Yeah. The server has well, HTML page, or actually these are statistics from Prometheus. Anyway, people that do metrics like this style of presenting statistics. Well, you can see, but the little file server, HTTP server, knows about a lot of file names, and 2000, 2400, 2 build IDs, and it actually worked, really. Okay. How do I get back to my presentation? Sorry. Where's my presentation? Sorry. Oh wait. And now? Yeah. Okay. That's good. Thank you. Okay. Okay. So what did we see? What does it do? Um, um, uh, you put all your debug info files in directories. You can tell it to scan RPMs, depths, your full build. What? Anything. Yeah, well, it does need a bit of information to cross-reference them, especially for the, yeah, right, for the source files. That's not always easy. Sometimes on Fedora, source files are put in a separate package from the actual debug info. So that is somewhat tricky. So. Uh, you can basically let the server running. It scans what you have. If it is a build directory, it also will clean up what's not relevant anymore. If you put new RPMs there, it will index them. Well, it's basically a little SQL. SQLite database. And it also supports DWZ, which makes the indexing also a bit tricky because DWZ compresses debug info by putting common elements in a separate file, but essentially a DWZ file is also something with the build ID, and you can just request it. I feel a question coming up there. Okay. Well, basically, SQLite is nice. That's a message from this this slide. Yeah, oh right, yeah. So it indexes everything, and you can really nicely partition what you do, because you can make servers query other servers. The debug info, the server is also a client, so you can say if you don't have the build ID, go one server up, and you could do the same inside your company or your programming group, where you have one server that questions all the others. Yeah, so the client caches everything, which also means the servers cache everything, and there is there is kind of a sample client in elfutils, the debuginfod client, but it's not much work to create your own clients. The sample client just uses libcurl and has a least recently used cache of files. Well, basically, to implement the client, you have to be able to make HTTP requests, and that's it. this was the minute slide. Thank you. This was actually the slide I was describing with the client, sorry. Let me go back what I should have said here. No, this is good. I already said most of this, but the scanning can take long, mostly because the RPMs are compressed. The decompressing reading takes most of the time. The database can become a bit large, but that's mainly because there is so much data, especially if you try to index all the RPMs in the Fedora Koji build system. That is really big. But in these, it's a very parallel problem. You can just partition it. You can have multiple directories, multiple servers. You can even merge databases. So like I said, there's an implementation of the server and of the client in elfutils that was released in last month, I believe, in 0178. There is now support for deb files and for more parallel parsing of your directory trees in the current Git directory. For the next release, there's a prototype GDB client on a branch. It works perfectly. Tom, are you going to review it? Yay! There are several clients underway. I have a little list, and there are already some public servers if you want to try it out. Right. So this is actually already too old because this slide was made before the weekend. But there are two experimental servers now. One for system tab that Frank is running, and one for SUSE. They are Frank is trying to get the most common binaries that you use with system tab for all the different distros there. The OpenSUSE one tries to index all of the tumbleweed is the last one for OpenSUSE. They're both experimental, so if they don't work, sorry. But hopefully others do that. We had a talk with Alex Larson, I believe, who does the flatpaks, and he was also looking at making a server available that serves the debug info for flatpaks. And he actually wanted to write his own server, but the server is so simple that you can also do that. So for the clients, so of course the elfutils tools use it by default. System tab uses it because elfutils provides it. Dwars the same thing. The binutils, some binutils can use it. That's merged in Git. The GDB patch is proposed, and Tom is going to merge it. No, but and there are some in progress. I believe NO check was also recently done. try reloading that page. There's also some help wanted, and we volunteered Aaron for most of the work, but I'm sure he wants help. Yeah, so for the client support would be nice, either directly or using the elfutils simple client. Okay, I don't know what that is. You should think about security for the server a bit more. Oops. Of course, the debuginfod needs always to be improved, but that's, well, if you can help with that, that would be nice. If you could run a server for your own stuff, that would also be nice. Let us know, then we put you on the page and we get lots of people debugging your stuff because it's so easy. Well, and I think we hit the right spot by making it file-based, build ID indexed, but we might want to see if we can improve the protocol either by making things, making it smaller. For example, I just want the DIE tree for this thing, or just the file table, so I don't have to have the whole debug file. And maybe the other way around, for example, if you try to trace all the modules in the kernel, then you currently have to fetch 2,000 debuginfo files separately, and maybe you can batch that. But I think the current setup is so simple that it's good that we started with this. Do I have time for questions? Yes. Okay. But there are no questions.
I had some questions. They're kind of minor things, but I was curious what was wrong with the Nix approach.
What was wrong with the Nix approach? You mean?
Like the Nix
So,
of
yeah.
Nix
Yeah. Well, there's nothing wrong with it, but it is a much more complicated client. It's a fuse file system, which is nice, and I think what we have now is easier to set up and easier to federate, and I think that's something that is good. I think you could maybe take that fuse file system approach and build it on top of this. Yes, go ahead.
Is the server being run on, does it have to be run where your build directory is? Because potentially, if that's the build directory, it's also the build host, maybe, and
yeah,
it might be.
Yeah, so yes, it has to have access to your build directory, but you could maybe have your build directory mounted, yeah. But you're right, that is one of the things. That's also why we have separate indexing of RPMs and whole file trees. You could make it smaller. The interesting thing about having it on the host is that you are sure to also have all the header files as installed on the host. So in a way, you have to have it on the host to have the complete picture. Okay, I think I stopped before being dragged off the stage.